In this video, we're going to take a look at the same examples that we did with long division, but now we're going to work them out with synthetic division. So the benefits of long division are that it works the same way every time. It's a very steady process, but it does take a long time. So we need another process when we just need to divide something quickly that's simple to use with synthetic division. So let's look at example 1. Notice it's the same problem we worked out with long division, so we'll look at that and compare them in just a second. But let's just focus on synthetic division. So what you want to do first is make sure you have a 1 in front of your leading coefficient of your divisor. And then you want to change the sign of this number. And the reason we do that is we're going to divide using the root. So you think of x plus 5 equals 0. The root would be if we solve for x. So if we subtract 5, we get the root is x equals negative 5. And we're going to use that root. So put negative 5 in a little box over to the left. The next step with synthetic division is to take the coefficients of your polynomial and you make sure that they're in standard form first. And usually they are, but just be sure it's in standard form. That means it's from the highest exponent down to the lowest exponent. So x squared plus 7x plus 10 is in standard form. I can bring down 1, 7, and 10. Then draw a line, but leave room for another row of numbers. The next step is to bring down the first number. So we just drop down the 1 to get started. And then we start the process of multiplying and adding. So we take 1 that we drop down, multiply it by the negative 5, write it under the 7. So 1 times negative 5 is negative 5. Then you want to add the 7 plus the negative 5. So 7 plus negative 5 would give us 2. And then we start that process over again. So I'm going to erase those arrows. All right, so we'd say 2 times negative 5 and drop that number underneath the next number, which is 10. So 2 times negative 5 is negative 10, and then we add. So you add 10 plus negative 10, which is 0. If you would like, you can put a plus sign out here to remind you you're adding those numbers together. All right, so I'm going to move these arrows, and let's compare what we've got so far with long division. So now you have 1, 2, and 0. And our quotient for number 1 using long division was x plus 2. So what happens is in synthetic division, you're using your coefficients to generate the coefficients of your solution, your quotient. So what you want to do is take your coefficients of your solution, of your quotient, and you want to put back in the variables. But you have divided. Think about you divided something that was squared by x, so it's smaller now. So we have 1 less power. So 1 goes with x, and 2 doesn't have an exponent, so we just leave it out. It doesn't have a variable. But you want to put the variables back into your quotient. So in other words, we have x plus 2. And then we had no remainder, just like we did with long division. All right, so let's look at another good example. For example 2, you first want to make sure that your divisor has a 1 right there, a leading coefficient of 1. And in this case, it has a 5. So what we have to do is divide everything by that number. So this is an example of where synthetic division may not be your first choice because it does take this extra step. All right, but let's work on it and show you how it works out anyway. So we have 50 divided by 5 is 10k cubed. 10 divided by 5 will be 2k squared. 35 divided by 5 is 7k. And then we have minus 7 fifths. So just leave that. Don't worry about the fraction for now. It'll come out okay in the end. And then we're dividing by, and now we have 5 divided by 5 is just 1k minus 4 fifths. And remember, we want to divide by the root. So we need to find the root. So let's say k minus 4/5 equals 0. So all you would do is add the 4/5. So our root is k equals 4/5. So let's put that in the box. We need to find the root. And once you get used to the process, you can kind of tell that you just change the sign once you have your leading coefficient equal to 1. Then let's bring down our coefficients. So right there we have, let me get another color. We have 10, 2, -7, and -7/5. It is in standard form because we have k cubed, then we have k squared, and then we have k to the first power. So we know it's in standard form. Let's write our coefficients. So we have 10, 2, -7, and -7/5. Notice I didn't write any variables. Synthetic division uses the coefficients to generate the coefficients of your quotient. All right, let's draw a line, leave room for another row of numbers, and let's bring down the first number. We always want to just drop that one down to get started. So you have 10 to get started. We would say 10 times 4/5, and we would place that number underneath the next number, which is 2. So 10 times 4/5, let's think, 10 times 4/5 would be 10 times 4 divided by 5. So what's 40 divided by 5? That would be 8. So let's put 8 underneath the 2. And then we add those together. So 2 plus 8 would just give us another 10. Well, we know 10 times 4/5 is 8 already, so let's write that under the next one. So just so you saw what happened there, I said 10 times 4/5, but I already knew it was 8, but I want to place it underneath the next number, which was -7. And then we add -7 plus 8, which is 1. And then we do it again. We say 1 times 4/5, that root, and then we place that number underneath the last number. So 1 times 4/5 is 4/5. And notice right there they have a common denominator, which is why I said not to worry about that fraction, because it helps in the end to just leave it alone. So you have -7/5 plus 4/5. Let's just figure that out. So -7/5 and 4/5 have a common denominator. We can add the numerator together, so we get -3 and then keep the denominator like it is. And that's it. All right, so now what we have is our coefficients of our quotient. We just need to add back in the variables. So instead of writing k cubed, that wouldn't make much sense because you've already got k cubed in the original problem. I went too far. Let me erase that. So you've already got k cubed in the original problem divided by k. So it gets 1 smaller than where you started from. So k cubed divided by k would make sense that this answer starts with k squared. And then we just fill in the rest. So k squared, 10k squared plus 10k plus 1. And then you have a remainder of -3/5 because 1 is your constant term. You don't want to just combine those two. Each one of those numbers holds a place in your quotient. Now, there is something we can do to write this in a way that looks a little nicer. So let's put 10k squared plus 10k plus 1. But let's think of -3/5. So -3/5, if we were to take that number and divide it by our divisor, which was k minus 4/5. That looks really terrible because we have divided a fraction by something that has a fraction included. And so all you have to do to clean that up is multiply the top and the bottom by that common denominator of 5. And then it's going to look a lot nicer. So you're just multiplying back by the 5 that you divided by originally. So let's write 10k squared plus 10k plus 1 minus, and notice these 5s are going to cancel out in the numerator. So you have -3 divided by 5k, because you would distribute. So 5k minus 4 divided by 5 times 5 would cancel out the 5s. So if you look at the long division example, we have the same answer. So you might notice that either way, that problem takes some work. You might want to just do long division with that one, since it did take a lot of extra steps to get synthetic division to work out. But regardless, it's a multi-step problem. So either way, you could get there. Let's look at example 3. So we did it with long division. Let's look at it with synthetic division. So let's find how to set it up. So I would still recommend that we write it out with the missing variable. So 4g squared plus 0g minus 9 is still a great thing to do first. But we're dividing by 2g plus 3. So with synthetic division, you want to make sure that that leading coefficient in your divisor is equal to 1. So this must equal 1. You can't skip this step, or else synthetic division will not generate the right answer. So since that's equal to a 2, we've got to divide everything by 2 so that it will equal 1. So no skipping that step. So let's bring down what we have after we divide by 2. We would have 4 divided by 2, which is 2g squared. 0 divided by 2 is still 0. And just leave the fractions, because you saw in that last example that they work out in the end to have a common denominator. It's divided by g plus 3 halves now. All right, so let's find the root. So the root comes from your divisor if you set it equal to 0. And you would say, I could subtract 3 halves to get g by itself. So the root is negative 3 halves. So let's put that in our box to the left. And then we want to bring down our leading coefficient, or excuse me, all of our coefficients of the polynomial now that we've got it set up with after our dividing by 2. So we have 2, 0, and negative 9 halves. So 2, 0, and negative 9 over 2 are our coefficients of our polynomial. And now we're going to get started. So let's bring down the first number, which is the 2, to get started. And then we're going to multiply the 2 by the root, and then write it underneath the next number, which is 0. So 2 times negative 3 halves would be 2 times negative 3 divided by 2. So the 2's kind of cancel out, and you end up with a negative 3. And you certainly could use your calculator to help with that. And then we're going to add those together. So 0 plus negative 3 is negative 3. And then we do that step over again. So negative 3 times negative 3 halves, and we write it underneath the last number. So negative 3 times negative 3 halves is negative 3 times negative 3, which is 9 halves, because it's like a 1 times 2 at the bottom. All right, so let's write that down, and notice if you leave those fractions like they are, they do work out. So we're going to add those up, negative 9 halves plus 9 halves, which is 0. And then you just have to write in your variables of your quotient, because these are your coefficients of your quotient. So I have 2, negative 3, and 0. You would never want to combine those numbers. Each one of them holds a place in your answer. So we have 2. You always use 1 less than what your polynomial started with. So 2g minus 3. Basically, you have a remainder of 0, but you never have to write remainder 0. That's where we just know that this is a factor of the polynomial if we were asked. All right, so that's it for synthetic division examples.